Hi, thanks for watching the video. This is Mr. Bowman, and in this video we're going to talk about geometric sequences. So the focus of this video is on geometric sequences. Our previous video, or one of our previous videos rather, was about arithmetic sequences. So a geometric sequence is one in which the ratio of consecutive terms is always the same, called the common ratio. Another way to say it is that you could always multiply the previous term by some number to get the next term in the sequence. Here are some examples of geometric sequences. The sequence 2, 6, 18, 54, 162. What can I multiply each term by to get the next term? It's 3. 2 times 3 is 6. 6 times 3 is 18, and so forth. Here, the common ratio we usually use R is 3. Something that's worth pointing out there is another way to find the common ratio is to take one term and divide it by the previous term. Check it out. If you take 6 and divide it by 2, you'll always get 3. It also works if you take 18 and divide it by 6. And it works for 54 divided by 18. So if you don't see what that common ratio is right off the bat, don't fret too much. You can always take two terms that are consecutive. Take the second term and divide it by the one right before it. It should tell you what R is. Can you figure out what the common ratio is here for this sequence? 10, 5, 5 halves, 5 fourths. If you don't see it, think about the trick we just showed you. 5 divided by 10. Yeah, it's a half. Our common ratio here is a half. If you multiply each number by a half, you'll get the next number in the sequence. What about this one here? Yeah, for this one it's negative 2. 1 times negative 2 is negative 2. Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8, and so forth. So just like with arithmetic sequences, we have a rule that will find an expression for the nth term of a geometric sequence as well. A rule for the nth term of a geometric sequence is a sub n equals a sub 1 times r to the n minus 1 power, where r is that common ratio and a sub 1 is the first term in the sequence. So let's practice finding a rule for a geometric sequence using that idea. Alright, so here is a geometric sequence. It's the sequence 6, 2, 2/3, 2/9, 2/27, and so forth. We need to know two things in the rule to use our idea to find the rule for the nth term, I should say. We need to know what that common ratio is, and we need to know what the first term of the sequence is. That one is pretty easy. The first term of our sequence is 6. That's a sub 1. Can you tell what the common ratio is? Well, if you don't see it right away, take the second term and divide it by the first. 2/6, or even better, 1/3. There's our common ratio. And now you know the two things you need to write the expression for the nth term of this sequence. Now a sub n is, well, let's see, a sub 1 is 6 times 1/3. Since I want to make sure I get that whole fraction in this n minus 1 power, I need to put that in parentheses probably. Let me share with you quickly a mistake that I commonly see students make. They will get this, and then they will write this for the answer. You know what's wrong with that? It's lousy order of operations. We don't know what n minus 1 is, and in fact, for whatever term you pick, n might be different. So I can't really tell you what 1/3 to the n minus 1 power is, and I would need to be able to simplify that before I multiplied that number by 6. So do not do this. Don't do this. Stop here. If you want to check and see if we've got this right, one thing you could do is you could pick a value for n and plug it in and see if we don't get the term we should get. Let's take n is 4. Let's do that real quick. Let's let n be 4. If our rule works, we should get 2/9. So, just checking it out, a sub 4 would be 6 times 1/3 to the 4th power. No, 4 minus 1 power, rather. 4 minus 1 is 3. What is 1/3 cubed? It's 1/27. Or I'm going to come up here, 6/27. Does that reduce to 2/9? Yes, it does. We've got it. Thanks for watching.